that the first thing is that we have an electron, right? We have an electron and we have this tube, right? Or this plate which has two charges. So let's say we have this tube, this tunnel, and this one has positive charge. And this one is negative charge. Right. And we know that what is the direction of the electric field. So this is the direction of the electric field from positive to negative, right?
Yes.
So, and this is the electric field, and this is uniform, right? So this electric field is uniform. Means that this is a constant one. Constant electric field, and this is not changing with position, right? This is not depending upon the position. So the uniform electric field, I can represent it as, let's say 3I plus 4J. So this is the example of uniform. And if I have variable electric field, so variable electric field would be in this form. So let's say this would be 3x I hat plus 4x square j hat. So this is the variable one. You can see that this is depending upon the position. This is independent on this position. So these kind of fields are uniform. These are variable. So is this part clear?
Yes, sir.
So we have some uniform electric field. And now let's say we have at this junction we have a proton. Right, this is a proton. And let me just denote it by P. Right, so P is proton. So proton has positive charge, right?
Yes, sir.
Proton has positive charge, and I provide this charge a horizontal initial speed. So this is the initial speed that I provide to this charge. And because you see that this is experiencing some acceleration or some force in this side. So this charge is experiencing the force in this side. Right. So the force direction is this one. So this charge will move in this way. Right. So this is how the charge will move. Okay. I have provided this velocity, but this will go like this. So this is the trajectory of this proton. Right.
Yes, sir.
Now, can you tell me that how many components are there for the velocity of this proton? This is motion in 1D or 2D?
It's 2D.
2D, right? Because we have X part and we have Y part. So we have X part, we have Y part, right? So this is how the proton is moving. Good. So this is 2D, right? So
Yes, sir.
then if we write kinematics of motion, so kinematics of motion will have two components, right? And
Yes, sir.
what would be that? So kinematics of motion. It will have two components, right? And we
Yes.
have to figure out that one would be x component and the other would be y component.
Yes, sir.
So x component, what would be the equation of x component? Equation of x component would be Vx would be ux plus axt, right? And what is the other part? You have x distance. This would be uxt plus axt square, half axt square. And then the third equation would be what? This would be Vx square minus ux square. This is 2ax and then x. So these are the velocity that you have. Yes, Thameem, you got disconnected.
Hello, sir. Can you hear me?
Yeah, I can hear you. You got disconnected. Something is happening with your internet, right?
Yes.
Okay, I'm today. Okay. So, yeah, you have x component and then you have y component. So, what would be the y components? Y components would be vy. This would be uy plus ayt. And then the second part would be the y distance. This would be uyt plus half ayt square. And then the third part would be vy square minus uy square. This is 2ay and this is y. Right, so these are the x and y components. Are these points clear to you?
Yes, sir.
Okay, so if these things are clear, then let us write the initial conditions. Right, let us write the initial conditions. So we know that this distance is the length of this tube. So we have this length of the tube, which is L. So this is the length of this tunnel, whatever it is, tunnel or tube. And then this is the height of the tunnel. And let me write it as h. So this is the height. Right, is it clear?
Yes, sir.
Now, we are providing the horizontal speed to this proton. So what component is 0? What component is what? So you have ux component and you have uy component. Which component is 0? Can you tell me? Remember, this is the x component and this is the x component, this is the y component. This is the x component, this is the y component. Initially, this is here. And we are providing this velocity. So what component is 0? What component is non-zero?
X component.
X component is what? 0 or non-zero?
It's 0.
In x direction, we are providing this proton the u velocity. Right? So this is in x direction. We are not providing any velocity in y part. So this is 0 and this is u. Is this part clear?
Okay, sir. Yes, sir.
Okay, so this is done. And what is the x distance? X distance is L and y distance is h. So these are the other things that we have. Now, the other important thing is that what is the acceleration? So we know that only the force which is acting, that is in this direction. So force is in this direction only. This is the force. This is the force. This is the force. Right? Let's say this is the force. So force is in this direction, upward direction. Right? And that
Yes,
is
sir.
what? Force is how much? That is QE. Right? Who has joined? How many people have joined? So force is QE. And what is the charge on the, let me write it in here. So let me write this thing in here. So force is QE, and that is in upward direction. So this force is MA, and this is QE. What is the charge on proton? That is E, right? So we
Yes,
can
sir.
calculate that acceleration is EE by M. And what is the direction of the acceleration? Can you tell me? What is the direction of the acceleration?
Upwards.
Upwards, because force is upwards, so direction of acceleration is same. So this is upwards, so which will be Y component. And there is no force in the X direction. So then we can say that AX is 0, AY is EE by N. Is it clear?
Yes, sir.
Okay, so this part is done, and these are the only things that we will use. So let's now the question is that what is the time taken by proton to cross this tunnel? Right, this is the question. Now, to cross the tunnel, how much is the distance that it has to cover? How much is the distance that it has to cover? Yes.
Uh,
So it has to cover either h distance or either this L distance, right? We can apply
yes, sir.
both the conditions, right? So we can apply both the conditions. So we can write that this thing, right? So either we can write this thing or either we can write this thing. So let's apply the second case. Let's apply the second case. So from second equation of y component. What is that? We have y. So who got yeah, so y is uyt plus half ayt square. This is my y, right?
Yes, sir.
And I know that uy is 0, so this part is cancelled. And I know that what is this y? This y is h. And this is equal to half. Ay is how much? This is EE by m and then t square. So this t would be how much? This t would be 2hm divided by E into E. So this is this would be the time to pass this time. Is it clear?
Yes, sir.
And you see that this is not depending upon this initial velocity, right? So whatever you provide, it is only dependent upon this mass, this h, and this e, and this electric field. So
Yes.
whatever initial velocity you provide, that is totally independent of that. And then let's say that the time that this proton takes to cross this tunnel is this one. So you see that this H is constant, this E is constant, this E is constant. So T is directly proportional to root of M,
Okay, sir.
right? Now let's say that this is time taken by the proton and this is mass of the proton. So this is dependent upon the mass of the proton, right? Now
Yes,
another
sir.
question would be that, which will cross the tunnel faster, electron or proton? So we have another question that we are throwing the electron as well. So we have an electron which is also crossing this thing. So we have an electron which is here and this is crossing this thing. So this is following this path. Right? This is the electron.
Yes.
This one is proton. So this red one is the proton. This green one is the electron. So which will cross this tunnel faster? So that is the question. So let's again look at the question. What did we get? We have got that Tp is directly proportional to root of Mp and T electron. That would also be proportional to mass of the electron. So if we divide this thing, Tp by T, this would be root of Mp divided by Mp. So now you can tell me that which mass is bigger, mass of proton or mass of electron? Which one is bigger?
Mass of proton.
Mass of proton is bigger. So this mass of proton is bigger than this thing. So this would come out to be greater than 1. This is
Yes.
greater than 1. So you see that the time taken by the proton, this would be slower. So time taken by proton would be more as compared to the electron. So the answer is that electron will cross first. Right, that is the answer. So these are the questions which uses the idea of the force on a charged particle. So please note it down and then we'll talk about the other thing. So is this one clear to you?
Yes, sir.
Okay, then please note down this thing. So please note down this question. And whenever you want me to scroll down this thing, please tell.
Okay, sir.
Yeah. So to cross the tunnel, this is the thing that we have.
Okay, sir.
Please note it down, and then we'll do the next document. Yeah, whenever you want me to scroll down the screen, please take.
Okay, sir. You can scroll down. Done, sir.
Yeah. Okay, so now we have done this topic. So let us recollect whatever we have done so far, right? And you please also take a glance of whatever we have done so far, right? Because the exam is near. On 4th June, you have your first unit test, right? And after that, you'll be having your vacations. So just recap all those things, right? So what we have done so far. Firstly, we have talked about basic features of charges. Right? Did we talk about this thing? So did we talk about quantization, all those things? Oh, we have started with the Coulomb's law. Yeah, basic properties we have, right? Basic properties we have. Okay. So firstly, we have talked about basic features of charges. This is the first thing that we have done. Secondly, we have understood or we have discussed the Coulomb's law. Right. And the next topic that we have done is the equilibrium. And there were two kinds of equilibrium. One was that one point was at equilibrium. The second equilibrium that we have done is that system is at equilibrium. Right. And then the fourth thing that we understood was the superposition principle. Superposition principle. And this was for the Coulomb force. Right. What was the idea? So F was the vector addition of all the other things, right? So this was the thing. And what was this Coulomb law? So this was simply K Q1 Q2 divided by R. So this is the thing. And in Coulomb's law, we understood about the medium as well. So in medium, this thing F becomes FAS by this K, right? Where this K is the dielectric constant. So this is the thing that we did. And in Coulomb or in superposition principle, we talked about vectors. So we understood about vectors. And then after talking about vectors, in bridge course, we talked about calculus. Right, so these are the things that we have done. The fifth part was Coulomb's law in vector form. So in this part, what did we understood? In this part, we understood that F12 is simply K R1 minus R2 vector divided by this is Q1, Q2. And then this is R1 minus R2 mod Q. So this was the Coulomb's law in vector form, right? Where R1 and R2 are the position vectors.
Yes.
Of two charges. And then the sixth thing that we have understood or we have discussed was the electric field. Right. In electric field, the first point that we have talked about is that what is the electric field for point charge? And this is simply k cube by r square. This thing we have understood. The second thing we have talked about is the superposition principle of the electron. Right.
Yes, sir.
And again, we saw that this E was simply E1 plus E2 plus vector sum. The third thing that we have understood is the dipole. And let me write it in here. So we have talked about dipole. What was the dipole moment? So first we talked about dipole moment, and this was charge into the separation. So this was dipole moment, and then we talked about the electric field of the dipole. So how many electric fields were there for the dipole? Do you remember?
Uh,
There were two. One was axial, the other one was equatorial. Axial electric field was 2 kp divided by r. And then equatorial was minus kp by r. So this is these are the things that we have understood in the dipole part, right? The eighth thing, the last topic that we were doing was the force on charged particle in the presence of electric wave. So this is the current topic that we were doing. So one topic that I have not covered and that I'm keeping for the last is in between all these topics, and that one is because that is a totally conceptual one. So this is miscellaneous and this is in between, let's say 7.5. This is electric field lines. So electric field lines, this I will tell you in the very end. And in this one, we have to just remember 8 properties. So there would be 8 properties of the electric field lines that we have to understand. And this is purely conceptual. So that is why I'm keeping this thing for the very end, right? So
yes,
the
sir.
next topic that we would be doing is the torque on a dipole in the presence of electric current. So this is the topic that we will be covering now, right? And all these topics, so these are the topics that we have done. So please revise these things. And if you find any topic which is difficult for you, then please let me know. I will describe or I will explain that thing again. Please go through all these topics, right? So what is the
Yes.
chapter that they are doing in your school? What is the chapter?
What's it? Can you repeat it again?
Yeah, what is the chapter that they are doing in your school in physics subject?
Hold on, sir.
Yeah, are they in
It's
the first chapter or they are in the?
for the class.
Yes.
No. We're not in the first chapter. We finished. For the past few weeks, there have been no classes
Oh,
because we have some program happening, so there wasn't any class for 2 weeks.
oh. So in 2 weeks you didn't have any class. Okay.
Yes, sir.
And yeah, so they have already completed all these things. They have already completed the first chapter.
Yes, so we finished the first four chapter. We were in the third chapter, I guess.
Even the third chapter.
Yes, sir. I think they're like next week we'll complete the third chapter, I guess.
Third chapter. Oh, so okay, third chapter. And we are currently in the first one, so we have the second one also, and then third chapter is electric current. So they have already completed this electric current. How fast they are going. So these are these are major portions of your physics subject, right? These are very big chapters. The first one is the biggest chapter of them all, right? So it requires proper explanation of each and every topic. So I don't know
Yes,
how
sir.
did they. When was your school started?
It started, I think, at March.
In March.
Yes, sir.
Uh, in the middle of the March or at the beginning or in the end?
I think it was March 14th. I'm not sure.
Oh, in the middle of the March. So March in the middle, and then April, and so in 1.5 months, right? In
Yes,
the
sir.
end of because in 2 weeks from the last 2 weeks, no classes are happening. So I guess in the end of April they have in 1.5 month and they have completed 3 chapters. I don't know. Okay, because our
Yes, sir.
classes happened started in April, right? In the middle of the April, right?
Yes, sir.
Yeah. So okay, so that is not that important, but we will try because your exam will happen in the 4th of June. So they will ask, I guess, 3 chapters. So first 2 chapters we will complete, and then the third chapter we'll do in the vacation. So we can cover up all those things. But yeah, we'll do for the preparation of the things we'll do the important questions. So, but you please revise all these things, right? These are very important. So yeah, you please revise them. And if you face any problem in understanding any of the topics, please let me know, right? So please let me know. Okay, so the next topic is talk. Have you heard of this name before? Have you heard this name before?
Yes,
Yes.
sir.
You have already heard. So where did you hear this thing?
Uh, in cars and all, like
In cars. Okay,
cars.
yeah.
Yes.
Okay, in cars you have okay in cars and oh maybe so yeah that thing is there in your cars, right? Okay, yeah.
Yes,
So
sir.
this and that is related because cars have those wheels, right? So in wheels you have you must have heard this talk, right?
Yes, sir.
And those wheels are rotating, right? Those wheels are rotating and they are connected with some metal bars. So those metal bars are there and those wheels are connected, and then those wheels are rotating. So yeah, you are absolutely correct. And give me one moment. So there is someone at the door. Please give me one moment. I'll be back in let's say 2 or 3 minutes. Give me 2 or 3 minutes. I'll be back.
Okay. No problem.
Yes, yes, sorry for this, wait, yes, so I was, yeah, are you here? Thameem?
Oh yes, sir. Yes, it's
Yeah,
alright.
sorry for making you wait this.
Oh, it's alright.
So yeah, what we were discussing. So yeah, whenever we have some rotating things, then we associate the force with this torque, right? So torque in a dipole in the presence of, in the presence, so in presence of electric field. Right. So before we talk about this torque, right, let us understanding about what this torque is, right? So whenever we have a rotating thing, so the force that is associated with the rotating thing, that is what we call torque. So let's say we have this bar, and then we are providing this force in this direction and this force in this direction. So what do you have? So this thing, this bar will rotate, right? So whenever you
Yes.
have a force and then you have some axis, so this is the axis, right? And on this axis, you apply the force in different directions. So then that will create the torque. So let's say we have this thing, right? So we have this bar, and let's say one force that I apply is in this direction. So I'm applying one force in this direction, and then the other force in this direction, downwards. So this will rotate, right? This will rotate, right? So whenever I have some
Yeah.
forces in the pairing, right? Whenever I have forces in the pairing, that creates the torque. So what is torque? Torque is simply the rotational analog of force. And there is an important torque. So there is a type of torque which is called a couple, right? So there is a type of force which is called a couple. And what is that? When two forces which have the same magnitude. Let's say this is F1, this is F2. So now when two forces which have the same magnitude, and they are acting in the opposite directions, then it is called couple. Right. So what is the meaning of that? So you have this force which is acting in this direction, and you have the other force which is acting in this direction. So both have the same magnitude, and they are acting in different direction. So this is called a couple. So the axis of this force is what? This is the axis. This is the line of force, or this is the line of action. So this is the line of action, and this is the line of action.
Yes.
So whatever is the perpendicular distance between the line of action, that is called the perpendicular distance, R perpendicular. So what is this R perpendicular? This is the perpendicular distance perpendicular distance between the line of action. Right. So this couple, which is also called the torque, this is defined as the magnitude of this R perpendicular and then this F. So this is what we call the torque. Right. Is this
Yes.
part clear? Is this part clear?
Yes.
So this is the magnitude of the torque that we have. So you have this line of force and then the perpendicular distance between them. So if you multiply this R perpendicular to this F, so you'll get the torque. Now, do you remember the cross product? Do you remember the cross product? Yeah.
Uh,
Do you remember the cross product? Cross product of two vectors. Do you remember this thing? A cross B. Do you remember this thing? What was A cross B?
yes.
What was A cross B? This was AB sine theta and n hat. This was A cross B. Remember?
Yes.
So the magnitude of cross product is AB sine theta. So please revise this vector portion because this thing would be recurrent. Vector would be recurring, so please revise those portion vectors. Please revise this. Otherwise, you will forget all these things, right? So please, again, I have been telling you again and again. So please revise those things whenever you get time. Just take a glance through your notes, and if you face any problem, please tell me. But the important thing is that you have to revise, right? So
Yes.
yeah. So cross product of two vectors is A cross B, which is AB sine theta. So this thing we have to do. Now let us talk about the torque. But yeah, before we do that, please note down these things. Please note down these things.
Okay, sir.
And then we can talk about the torque.
Yes.
Yeah, whenever you have noted these things, please tell me.
Okay. Done, sir.
Done. Okay, so now let us understand what would be the torque. What would be the torque for a dipole, right?
Yes, sir.
So let's write this thing. So the first thing that we will recap, right? So let us draw this electric field. And then in the presence of this electric field, we have a dipole. So what is the dipole? So let's say this is minus Q and this one is plus Q. So this is the dipole. Right, this is the dipole. Separation is 2A. Now, what is the direction of the dipole moment? What is the direction of the dipole moment?
Uh,
From minus Q to plus Q. That is the direction of the dipole, right?
yes, sir.
This is the direction of the dipole moment, and this is making an angle theta. This is making an angle theta with the electric field, right? Is this part clear?
Yes, sir.
So P and E are making an angle theta. So this is the first intake, and this is positive charge. Electric field is in the right direction. So what would be the direction of the force for this charge? What would be the direction of force? Left or right?
Right.
Right. So this is F, and this is how much? This is QE. Right.
Yes, sir.
For this one, for this minus Q1, what is the direction of the force? Right or left?
Uh, it's left.
Left, because this is a negative charge. So force is in the opposite direction. This is F, which is minus QE. So you see that one force is in the downward direction or right direction, the other force in the left direction. So you see that this is acting in different direction. They have equal magnitudes, right? They
Yes,
have
sir.
equal magnitude, so this will act as a couple, right? This will
Yes,
act as a
sir.
couple, and this would be the line of action. This one and this one. So this is the line of action. And this one is the line of action. Right.
Yes, sir.
And this one is the perpendicular distance, R perpendicular. Right. Is it clear?
Yes, sir.
Because you see that this is the line of action, this is the line of action. So the perpendicular distance between the line of action. So what would be the torque? Torque would be R perpendicular and then this force. Clear?
Yes, sir.
Okay, now we have to find out what is this R perpendicular. So you see that again, this resolution of vectors will haunt you forever, right? So we have to be, you have to always remember this thing. So this is 2A, this is theta. So what would be this component? which is making the angle theta. What would be this component?
Um,
Okay, let's say you have this thing which is A. This is making an angle theta. So what is this component? This is the horizontal one, and this is cos theta. Whatever is making an angle, this is the cos component. And whatever is perpendicular to that, that is the sine component. So this is resolution of vectors, right?
yes, sir.
So this would be how much?
Because
2a cos theta. And this is 2a sine theta. Clear?
yes, sir.
So this is 2a sine theta. Okay, so now let us write all the values, right? So now we can write the values. So this is 2a sine theta and f is QE, right? So what is,
Yes, sir.
let me just write this thing separately. 2AQ, 2AQ. And then we have E, and then we have sine theta. So do you remember what is this 2AQ? What would be this 2AQ? Can you tell me? If you remember the dipole, so what is this 2AQ? Yeah, what is this 2AQ?
Um, 2AQ is speed. um,
So 2A is separation, Q is charge. What is separation into charge? Dipole moment. Dipole moment is separation into charge. That is the dipole moment.
yes, sir.
This thing we have learned in the derivation of the electric field of the dipole, right? So this is
Yes,
P and this is E and then sine theta. This is tau. So can you tell me that what is AB sine theta? If we compare this PE sine theta with AB sine theta, then what is this AB sine theta? Do you remember? So this is the cross product. Remember that A cross B is AB sine theta, right?
yes, sir.
Similarly, P is sine theta, P is A, E is B, and theta is the angle between A and B. So P sine theta would be P cross B. So this is what we call the torque in a dipole. That would be the cross product of dipole moment and the electric field. Is it clear?
Yes, sir.
Okay, so please note it down. This is very important, right? This derivation is very important. So please note this thing down. Right, torque
Oh,
in dipole. Yeah, whenever you have noted it down, please tell me.
Okay. Done, sir.
Done. Okay, so we have understood that the torque in a dipole is the cross product of the dipole moment and the electric. Right? This we have understood. So you see that there there are special cases.
Yes.
Special cases for the torque in a dipole. And what are those special cases? So what do we have? We have this thing. This is the electric field, right? And this is the dipole.
Yes.
Now we can have, and this is the angle theta. So now we can have different cases, right? And what are those cases? So one case is that we have this dipole and we have this electric field and we place the dipole in this manner.
Yes.
So now can you tell me what is the theta?
0.
0 degree, right? So theta is 0 degree. Good. Theta is 0. So this is case 1. And another case would be this, right? So this is the thing.
Yes.
And you place this dipole in this way. So now can you tell me what is theta? What is theta? Remember, this is your theta. Yes?
It's 90 degrees.
90 degree, absolutely correct. So the theta is 90 degree in this case. Good. Now the last case, so we'll talk about all these cases one by one. Like how much time do we have? So yeah, we'll talk about all these cases one by one. So this is the electric field. Now you place the dipole in this way. But this is minus q and this is plus q. So can you tell me what is theta in this case?
0.
So remember the theta is angle between P and E, right? So what is the theta? What is the angle in this case?
It's 0.
So P is minus to plus, right? P is minus to plus, so this is in this direction. This is P. What is electric field? In this direction, right? So angle is how
Yes.
much? In this case, yes, in this case, P was this and E was this. In this case, P was this and E was this. So yeah, what is theta in this case?
180.
180 degree, right? So this is 180 degree. So you
Yes.
have this is case 1, this is case 2, and this is case 3. So these are the three special cases for the dipole. Please note it down, and then we'll start. So I will write all these special cases in the next class. But yeah, you please note this thing. Right. So
Okay.
yeah, so whenever you have noted there, please do.
Okay, sir.
So this is the dipole moment, right? And this is the electric.